Dear teachers and students, hello, I'm LI SEN. Today I'm very honored to share my thesis here. My research title is Prediction of the Impacts of Water Pollution Indicators on Diarrhea Incidents in Multiple Countries based on machine learning. First, I would like to talk about the background of this study. Diarrhea is one of the main causes of death among children in developing countries. And water pollution is an important factor causing diarrhea. From the picture, we can see that the water collection environment for children in these countries is very difficult. However, traditional monitoring methods are lagging and cannot provide forward-looking predictions and operability. Therefore, how to use modern technology to solve this problem has become the key to public health management. My research goal is to build a tool that can predict the incidence of diarrhea through machine learning models, which is both interpretable and practical, and provide support for disease early warning in resource-poor areas. About the data for this study comes from the Cargo Public Dataset, covering more than 3,000 records in 10 countries from 2000 to 2025, including 24 variables such as water quality, sanitary conditions, environment, and population. These characteristics are closely related to diarrheal diseases and provide sufficient information support for the model. In terms of data processing, I first cleaned the data, removed missing values and outliers, and then standardize each feature to ensure the model can fairly measure the importance of each feature. Then I screened out 12 features that have greater impacts on diarrhea prediction through correlation analysis and feature importance ranking. In fact, careful data pre-processing is crucial because poor data quality can significantly reduce model performance. So this step lays a solid foundation for all subsequent analyses. Afterwards, I compared 4 models: linear regression, decision trees, random forest, and XGBoost. The results shows that XGBoost performed best, with a coefficient of determination of 0.60 and the root mean square error of 90.7 on the training set, which has good predictive ability. So we used the XGBoost model to drop a bar chart of the top 10 most representative feature importances. By the way, we choose XGBoost because it can efficiently handle nonlinear relationships and feature interactions, which is very suitable for solving our problem. For example, built-in regularization prevents overfitting and automatically handles missing values, which is very important for actual deployment because field data is often incomplete. Okay, let's focus on model interpretation and innovation. In order to improve the interpretability of the model, I used the SHARP methods to interpret the model output. The result shows that lead concentration and bacterial count are the most important factors affecting diarrhea incidence. Sanitation coverage also has a significant effect on reducing risks. These results are consistent with epidemiological knowledge, which enhances the credibility of model predictions. So how about lightweight model and deployment? Considering the scenario of limited resources in actual applications, I chose a simplified model with two key variables, pH values and lead concentration. The R-squared of this model is about 0.52, although it is slightly lower than the complete model. The calculation is simple and efficient, and it can be easily embedded in mobile devices and field monitoring tools. It is worth mentioning that these two indicators can be quickly tested with test strips and portable devices at a cost of less than $1, which not only reduces the cost of testing, but it also convenient and fast. In addition, in order to facilitate the implementation of the model, we designed and implemented a prediction class called Water Quality Predictor, which can give the diarrhea risk level and predicted incidence rate for the input pH and lead concentration. The bottom figure shows the result of the water quality predictor code. Then, through modular design, this class can be directly integrated into the information systems of grassroots health stations and can also be embedded in mobile apps to help frontline health workers to tightly judge risks and take measures. Such models has been deployed in 20 primary health stations in Kenya. Let me tell you a real case. During the dry season last year, the system warned of abnormal pH in a village. Investigation found that illegal mining caused acid wastewater leakage, and timely intervention avoided a possible diarrhea outbreak. So I think the development of such models is very necessary. Finally, about practical application and future prospects. The value of this study is that it not only verifies the importance of environmental and health variables for diarrhea prediction, but also provides practical tools for public health decision making. In the future, I will further optimize the model, such as incorporating climate and time series characteristics and combining it with geographic information to improve the prediction accuracy, so that this research can be better applied to public health affairs. In the end, I would like to thank my supervisor, Dr. Rochalis, for his careful guidance, as well as the support of my classmates and the encouragement of my parents. This is the end of my report. Thank you for listening. If you have any questions, I'm happy to discuss with you. Bye-bye.